Imagine a beam of light moving slower than your car on a highway, just 38 miles per hour. Sounds impossible, right? But scientists have made it happen. The speed of light, often thought of as the universe's ultimate speed limit, isn't as untouchable as you might think. What's slowing it down? And how does this change everything we thought we knew about the laws of nature? Light is fast, unbelievably fast. In a vacuum, it zips along at 186,000 miles per second. That's the kind of speed we use to measure distances across galaxies. But what if I told you this universal constant isn't so constant after all? The speed of light can change, and it's all thanks to the weird ways light interacts with matter. Glass, water, and even human-made experiments have slowed light down to a crawl. Today, we're diving into the science behind this phenomenon, how it was discovered, and why it could revolutionize technology, from quantum computing to the internet. We've been taught that nothing in the universe is faster than light. But what happens when this seemingly unbreakable speed limit suddenly isn't so fixed? This question has baffled scientists for centuries. The speed of light has been a cornerstone of physics, used to calculate time, space, and even the beginnings of the universe itself. If light isn't always at its maximum speed, it means the rules we've built so many theories on aren't quite as universal as we thought. And here's the kicker. Slowing light down isn't just a quirk of physics. It's a challenge that could unlock breakthroughs in technology, or even redefine how we think about communication, energy, and transportation on a cosmic scale. But slowing down light isn't as simple as putting up a cosmic speed bump. So how do we do it? And what happens when we do? To understand how light can slow down, let's first talk about how light moves. In a vacuum, like space, light travels in a straight line at its maximum speed. But the moment it encounters any kind of matter, like air, water, or glass, it starts to interact with particles. These interactions cause light to bend, scatter, or even pause momentarily, effectively slowing it down. Think of light as a runner on an empty track. That's how it moves in a vacuum. Now imagine that runner entering a crowded marketplace. They have to dodge people, pause, and change direction. That's what happens to light when it moves through different materials. Here's an everyday example: water. Light traveling through water moves about 25% slower than it does in a vacuum. That's why a straw in a glass of water looks bent. It's the light bending as it slows down. Glass is even denser, slowing light by about 33%. But here's the mind-blowing part. These aren't the slowest speeds scientists have recorded for light. In 1999, researchers at Harvard University managed to slow light to just 38 miles per hour. How? By using a bizarre state of matter called a Bose-Einstein condensate. A Bose-Einstein condensate, or BEC, is a substance formed when certain types of atoms are cooled to just a fraction above absolute zero, the coldest temperature possible. At this extreme cold, the atoms clump together and act as if they're a single unified particle. This unique state of matter has some truly bizarre properties, and one of them is the ability to trap and slow light. In their experiment, scientists fired a beam of light into this supercooled gas. Instead of zipping through, the light beam almost stopped. It was as if time itself had slowed down for the light. This wasn't a trick or an illusion, it was physics in action. Here's what's happening on a microscopic level. The atoms in the Bose-Einstein condensate interact with the light in a very specific way. Instead of letting it pass through quickly, they absorb and re-emit the photons at a much slower pace. This delay stacks up, effectively slowing the light to a crawl. Now, you might be wondering, what happens to the light's energy? Doesn't slowing it down change its properties? The answer is yes. When light slows, its wavelength shifts, its color changes, and its energy dynamics transform. This opens up a whole new field of possibilities. Slowing light down isn't just a fun physics experiment. It's a game changer for technology. Imagine a future where we can use slow light to store data, process information, or even create unhackable quantum communication systems. By manipulating the speed of light, scientists could build computers that process information millions of times faster than today's fastest machines. And it doesn't stop there. Slowing light could revolutionize medical imaging, making it more precise and less invasive. It could enhance fiber optic communication, bringing faster and more secure internet to everyone. Some researchers even believe that understanding light's malleability could lead to breakthroughs in teleportation or faster-than-light travel. But perhaps the most exciting implication is what it means for our understanding of the universe. If we can control light, we might one day manipulate gravity, space, or even time itself. Light, the fastest thing in the universe, can be slowed down to speeds we can barely comprehend. From glass and water to cutting-edge experiments with Bose-Einstein condensates, we've learned that light isn't as untouchable as it seems. And by bending these rules, we might unlock a future filled with technology and possibilities we can't yet imagine. So, the next time you see a ray of sunlight streaming through your window or a laser pointer at work, remember, the speed of light isn't set in stone. It's a boundary we've already begun to push.